I'm Bob.
And I am Ross. Today we are going to be explaining the life cycle of a star.
And painting it.
Yep. The star begins as a stellar nebula. Eventually the particles begin to bond together due to their gravitational pull. The particles bonding are hydrogen, and they are creating helium particles, and then are creating a protostar. Friction from gravity continues to increase temperature of the protostar until it can create nuclear reactions. This phase lasts around 10,000 to 1 million years. In this phase, the star's temperature and density are proportional. They are about 2/3 the power of the nebula. The temperature is about 10 million Kelvin. This phase is short because the star is very luminous and uses up its fuel very quickly. The star undergoes many more reactive phases that produces a large mixture of various elements. As the shells are made by many nuclear reactions, the star expands to larger size. As the shells are built, the star becomes a supergiant.
The density of a star ranges between 10 to 70 solar masses. A star with about 8 to 20 times the mass of the Sun will end up with a core too large to be supported by electron pressure. Once the star can no longer produce energy, the core of the star will violently collapse upon itself, and this process takes 100 seconds and the temperature is around 100 billion Kelvin. Like electrons, neutrons resist to be close together. This creates a pressure that resists the collapse of the core. The core becomes a collapsed stellar remnant called a neutron star, which has a temperature around 600,000 Kelvin. The remaining layers fall onto the surface of the neutron star and explodes outward, creating a supernova, which enriches the universe. And that, ladies and gentlemen, is the life cycle of a star.